Alright, so half-life is literally the same exact thing as decay. The only difference is instead of seeing B as a percent, you're going to see it as a number, which what number is a half, or how do you write a half? 1 over 2 or 0.5, right? You need to make sure that when you're reading your questions, make sure the units by the numbers match. In other words, if the question is in months, make sure all the units are months, and you'll see what I mean by that in a second. So let's take a look at the question. As soon as you start a question, you're going to write down the formula. So growth and decay are always going to be this formula. The way you know it's compound interest is you look for that word that says compounded. But here, just this formula, you copy it down with boxes.
This is a listening check. Color in that first box.
Cesium dash 137 has a half-life. So that word half-life is how you know you're doing half-life. And all that means is they're not going to give you, like in this previous questions where they give you it's decreasing at a rate of 3%. That's what they're telling you there. So when you see half-life, they're saying your rate of decay is a half. So your rate of decay right here, your B, is a half is what they're saying. So go ahead and just put a half in there. So you can put 0.5 or you can put 1 over 2. Really doesn't matter, but I'm just gonna put a half. All right, so it has a half-life of 30 years, okay? Find the amount of this left from 100 mg sample after 180 years. So calculate how many times half-life goes into your total years, and you do that by saying total years divided by half-life and as your x. So that's what your x isn't just a time, it is total years divided by half-life. Okay, so for half-life, you do have this one extra step to do, okay? So to find this number here, basically, you take your total years divided by half-life. So what are my total years? It's telling you it has a half-life of 30 years, okay? Find the amount left from 100 mg sample after 180 years. X is equal to total, which is 180, divided by my half-life, which is 30. So there's an extra step when you're doing half-life is you have to find out how many times it goes into your total. But everything else is the same. Find the amount that's left from this. So you started off with 100. And they're asking you to find what's left after that. So the difference, once again, is going to be in your X, your time that has passed, your time period. To find your time period, you're going to do this when you see the word half-life. Okay, so punch it in the calculator, 100, open parentheses, 1/2. I'm just going to write 0.5. It's just going to be easy instead of having to do all these parentheses. All right, raised to the power of a fraction. Remember, fraction, you do it in parentheses, 180 divided by 30, close parentheses. So 1.5625.
This is a listening check. Put a box around this answer.
So let's take a look at another example. All right, so again, start off with the equation with boxes. Fill in the numbers as you do it in a circle, if it's a percent or it's a number. So actually in here is where this happens. Okay, so it's going to be a number that's going to be the number of half-life. So when you see half-life, remember to find my X total years divided by half-life. All right, so this chemical has a half-life of 5 days. So half-life, 5 days. Okay, so total over half-life. So I need to find the total. Find the amount of blah, blah, blah left from blah, blah, blah after 5 weeks. Okay, so this is my total. But this total is in weeks. Okay, so remember my units. So always make sure that my units have to be the same. So months, months, or weeks, weeks, or days, days. So let's first make this the same. How many days are there in 1 week? Okay, there's 7 days. So if I multiply this by 7 days, I will get 35 days. Okay, so I have to make sure it's days and days. Okay, I can't do weeks and days in the same problem. Remember, to find my X, I go total over half-life. So my total is 35. So here's my X, 35 over half-life. Half-life is 5. So that's my X. My rate of change, because I see the word half, is going to be 0.5. Okay. Find the amount left from this. So I started with 100. So that goes right there. And then So again, the biggest thing with half-life is just remembering this extra step, and it's just total over your half-life. Just make sure your units match up. All right, then go ahead and punch it into a calculator. So 100, open a parenthesis, 0.5, close a parenthesis, raise to the power of a fraction, which means anytime you have a fraction, put in parentheses, so 35 divided by 5, close it. So I get y equals 0.78125 mg. And it didn't tell me how they wanted it to round, so I just left it like that. But that's all there is. So anytime you see in decay something is decreasing, it's called exponential decay. If you see the word half-life, just remember to calculate x by doing total of the half-life. Let's practice.